my name is Julius. In this video, we are going to discuss the center of mass. What is the center of mass? The center of mass of an object is a special point that describes the overall motion of the mechanical system. There are various applications of the center of mass, such as the automotive application and the astronomers use it to calculate the barycenter. In this video, we are going to concentrate on how to locate the center of mass. So in such a case, the formula for calculating the center of mass is given by m1 d1 times plus m2 d2 over the total mass m1 plus m2. So in the first case, in a Cartesian plane, we have the x-axis, the y-axis, and the z-axis. So calculating the center of mass in accordance to the x-axis is denoted by xc, which is given by mass of object 1 m1 times the distance, and now in this case, distance is given by x1, distance in the x direction, plus mass 2 times the distance x2 over the total mass m1, as we have said, plus m2. So this applies also for y coordinate, which will be given by mass 1 times, in this case now the distance will be y1, plus mass 2 times its distance, which is y2, over the total mass m1 plus m2. And this also applies for z coordinate. So we are going to consider the first case where you are told to calculate the center of mass of numerous objects. In such a case, we denote it as RC, or you can take XC, is given by the summation. This is a summation sign. Summation of mass, which is denoted by MI, times XI over summation of mass MI. So this is the second instance. Now when we go to the third instance, when calculating the center of mass of infinitesimal objects, small objects, in this case, the summation sign, if it is the center of mass of the x coordinate, will be equal to, the summation sign changes into an integral sign. So in this case, it will be 1 over m, then the integral sign, then now it will be x is the distance, then dm, the mass changes to dm. So this is the mother formula for calculating center of mass of small particles. Take an instance of case 1, finding the center of mass of a linear object. Take a linear object on the x-axis like this. So the first thing we do, take a portion of the object, shade it, and name it as dx, because the total is x under the x-axis. So when we take the total length of this such object to be x, first write the mother formula, which said xc is equals to 1 over m, then the integral sign, x dm. So a linear object has something called the linear density, and linear density is denoted by the sign, which equals to mass over length. Lambda equals to mass over length. So in this case, length is on the x-axis. Now we take it as mass over x. The length is distance x, as you can see up here. But in this case, we took a portion of an infinite or a small particle. So in this case, the mass will be denoted as dm over dx. So in this case, lambda is equals to dm over dx. So making dm the subject of the formula, dm is equals to lambda dx. So the easy thing you do, you just substitute for dm back into the mother equation here. So the mother equation will be transformed into xc equals to 1 over m, then the integral sign x lambda dx. Since you cannot integrate a constant, we can further simplify the equation to be xc equals to, now the lambda comes out to be lambda over m, then the integral sign x dx. Thank you for watching the video, and stay tuned, subscribe so as to get the other cases in the next video, which we will deal with finding the center of mass of a plane object and finding the center of mass of a voluminous object. I hope you enjoyed and understood the topic. The topic might be a little bit challenging, but please stay tuned and you will get to learn more.